This is AND gate behaving like two switches in series, will give output only when both are working. That means if both inputs are high, so truth table is 1 0 0 0 1 0 0 0 is also 0 1 1 1. Completed. Third gate is called as NOT gate. Third, NOT gate. This gate is the most basic logic gate. This gate is most basic logic gate. It has only one input and one output. Rest all gates have minimum two. This has only one input and one output. It always inverts the input, that is 0 becomes 1 and 1 becomes 0. That means for high it will make low, and for low input it will make it high. It inverts the input, 0 becomes 1, 1 becomes 0. Hence also called as inverter. Also called as inverter. The symbolic representation and truth table, the symbolic representation and truth table is as shown. This is triangle, input. Here there is one circle indicates inversion, output. A, here X, Boolean expression is given by X equals to A bar or X equals to A dash. Sometimes it is also called as complement. X is complement of A, or negation of A, or inversion of A. Truth table A, X is A complement, 0 becomes 1, 1 becomes. Yes, completed.
Yes, sir.
Okay. So we studied OR gate, AND gate, NOT gate. NOT means just opposite. Fourth one, NOR gate. NOR means not or, उसका उल्टा. First see its truth table to understand what NOR gate is. It will give complement of OR. A, B, A plus B, X will be A plus B का complement. So we know 0. 0 will give answer 0. Complement will become 1. 1, 0, 0. 1, 0 is 1. That will become 0. 0, 1, 1 will also become 0. 1, 1, 1 will also become 0. So it will just invert the output called as complement. The NOR gate inverts the output of OR gate. Symbolically, it is represented as, this is OR gate, inversion. This circle shows inversion. So A, B should be A plus B. Here it becomes its complement. Write this, draw the diagram. Then Boolean expression is x equals to A plus B complement, or x equals to A plus B dash. Then write truth table. That circle at the vertex of OR gate indicates it is going to invert the output. Huh? Okay. मुझे इंटरेस्ट नहीं भाई. Yes, completed. Hello, completed till not get full truth table.
Yes, sir.
Fifth, right? NAND gate. NAND gate. The NAND gate is formed by connecting the output of AND gate to input of NOT. That means whatever AND gives, it will invert by NOT gate. Symbolically, it is represented as shown. This is actually AND. Here draw one circle that indicates inversion. So A, B, X. Boolean expression is X equals to A dot B and then bar, which indicates its inversion or complement. Write down, draw the diagram and write. Truth table. A, B, A dot B, then its complement. 0, 0, 0, complement 1, 1 0 1 0 1 0 will become 1. Last one 1 1 is 1, but its complement is 0. Completed this also?
Yes, sir.
Okay. One more last gate, exclusive OR it is called. Sixth one, exclusive or XOR, exclusive OR gate. This gate will give output only when one of the input is high, not both. Only when one input is high, it will give output. That means 1 0, it will give output. 0 1, it will give output. Both 0, it will not give output. Both 1, it will not give output. So that is called exclusive OR gate. Write down the exclusive OR gate. The exclusive OR gate goes high. Goes high means gives output only when its two input terminals goes high only when two input terminals are at different logic levels, are at different logic levels with each other. An odd number, this is if there are 3 input, 4 input, 5 input, then दो ही इनपुट है तो एक हाई चाहिए एक लो, but more than 2 are there, then odd number of high will give you output, and odd number of high, which is same as 1, at its input gives high, or 1 at output. Symbolic representation. Like or, and here if you put one semicircle, this is called exclusive OR. A, B, X. X is A plus फिर सर्कल डालते हैं B. This is exclusive OR, which is also A bar dot B plus A dot B bar. This is nothing but A complement dot B plus A dot B complement. It's called exclusive OR. Important है ये थोड़ा याद रखना. Truth table. A, B, X. X is output, A and B are input. Both 0 doesn't gives output. One high output. One high output. Both high no. Yes, completed.
Yes, sir.
Now for typical or specially designed junction diodes. For junction diodes we have to study. Zener diode is removed from the syllabus. Heading right, specially designed junction diodes. All junction diode works on only one principle. When forward biased, it will conduct. When reverse biased, it will not conduct. Forward biased means positive connected to positive, negative connected to negative. Reverse means positive connected, P connected to negative, N connected to positive. Specially designed junction diode. First one, light emitting diode, also called as LED. Light emitting diode. Now clear seed name is clear. Light emitting diode or LED, that means it should emit light. So LED or light emitting diode is a diode which emits light from atoms, molecule, nuclei. We know when electron jumps from unstable state to stable state, then it radiates energy. That light energy, if it comes in visible range, we can see. So that principle this LED is using. It emits the light when electron from one state to goes to another state. It emits the radiation which falls in visible range. Light emitting diode is a diode which emits light when large forward current passes through it. Forward current means when it is forward bias, passes through it. Symbolic representation. Light emitting diode is diode which emits light when large forward current passes through it. Symbolically, this is junction diode. This is P side. This is N side. It emits the light. So here you have to show the light coming out from here. Two rays. Right, this much. Yes, completed.
Yes, sir.
Right, construction. Construction. In LEDs, पीएन जंक्शन है मतलब पी और एन रहने वाला है, थोड़ा मॉडिफिकेशन के साथ. In LEDs, the N region is heavily doped. The N region is heavily doped. Then the P region of PN junction. N region is heavily doped. Then P region. It does not uses silicon or germanium. It does not uses silicon or germanium, but made with elements, such as gallium, gallium, phosphorus, and arsenic. By varying proportions of these elements, it is possible to produce light of different wavelength. Possible to produce light of different wavelength. Aluminium, gallium arsenide, aluminium, gallium arsenide emits infrared radiations. Aluminium, gallium arsenide emits infrared radiation. LED made using gallium arsenic phosphide, gallium arsenic phosphide produces either green, either red or yellow light. This is very important, which combination gives which light. Aluminium gallium arsenide gives infrared, gallium arsenide phosphide gives either red or yellow light. But LED made up of aluminium gallium phosphide emits red or green light, and zinc sulfide ZnSe produces blue light. Aluminium gallium arsenide produces infrared. Gallium arsenide phosphide produces either red or yellow. Aluminium gallium phosphide, red or green. Yes, completed. Hello, completed.
Yes, sir.
Only important is by adding the different combination of n-type, p-type material to which color it emits. Then write working of LED. This is p-type, n-type. P-type has positive hole, n-type has negative electron. This is made forward biased. If made forward biased with the help of factory B, then charges process the junction. In this case, positive, negative will diffuse. That means free electrons jump in positive hole which are present in valence bonds, and hence they fall from high energy level to low energy level and emit the light, emitted light. When made forward biased, due to combination of positive and negative charge, the electron from covalent bond, free electron jumps in valence band. Therefore, it goes from high to low and radiates energy which is in the visible region. Hence, we are able to see that light. Just draw this diagram for working. Right. When diode is made forward biased, when diode is made forward biased, the free electrons combines with the hole in valence band and releases sufficient energy and releases sufficient energy to produce photon which emits light which emits light. In bracket you can write single color. The output amount of light output is directly proportional amount of light output is directly proportional to the forward current. Thus, higher the forward current, higher is the light output. Higher the forward current, higher is the light output. The IV characteristics is as shown. Graph of current I versus forward voltage V is as shown. 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. This is in milliampere. 10, 20, 30, 40, 50. Till barrier potential, no current flows. So slightly you draw it inclined and then it rises. So this is IV characteristics. Up to certain voltage, no emission. Then current increases rapidly. Draw IV characteristics. Advantages of LED. Advantages of LED. First point, it consumes less power. It consumes less power. It consumes less power. Second, it has long life. Third, they are also called as solid state light. They are also called as solid state light, in bracket SSL. So sometimes they can ask you in exam, what is full form of SSL? Solid state light. They are also called as solid state light as they are made up of solid material. As they are made up of solid material with no filament. With no filament which can break. Fourth, it is instantaneous. Next, LEDs do not contain mercury or other hazardous substance. LEDs do not contain mercury or any hazardous substance. The brightness and color of light emitted, the brightness and color of light emitted by LEDs can be controlled. By LEDs can be controlled. Then write disadvantages of LEDs. Disadvantages. First, high initial cost. Second, temperature dependence. Highly voltage sensitive. Hazardous blue light quality. खाली ये blue light वाला थोड़ा hazardous है because it is using sulfide. Next, applications of LED. Applications of LED. Applications of LEDs. It is used in 7 segment display system. Now, if you have seen in as railway indicator, there are 1, 2, 3, 4, 5, 6, 7 segment display system. By making number of LEDs glowing, we can make this from integer 0 to 1. So that's why they can be used for 7 segment display. If all are glowing, it will resemble 8. If this is not there, it will resemble 0. So it can be used for 0 to 9 display system, called as 7 segment display system. Second, it is used in burglar alarm system because it emits infrared. That infrared is used to incident on photocell. So used in burglar alarm system. It can be used as on, off, toggle switch. टॉगल स्विच में तो ऐसा आवाज आता है, टक ऊपर किया तो ब्राइट होता है, नीचे डार्क. टॉगल स्विच. It can be used in signal system. It can be used in signal system. Next, it can be used as LED television. It can be used as LED television. Comma, vehicles headlight. Comma, domestic and decorative illumination. Domestic and decorative illumination. Decorative and domestic illumination. Second, right, solar cell or photovoltaic cell. Solar cell or photovoltaic cell. Heading written solar cell or photovoltaic cell. Right, there are two types of solar cells. There are two types of solar cells. First, just cancel, right, like this. It works on the principle. It works on the principle of converting solar energy into electrical energy. It works on the principle that solar energy is converted into electrical energy. Symbolic representation. So here this is PN junction. This time light is incident on it. So if you remember, if it is photocell, then it is this way symbolic representation. This is junction diode, which is converting solar energy into electrical energy, not any type of light. So this is symbolic representation. Next line. Two major type of devices. Two major type of devices two major type of devices converting solar energy into useful purposes are first one photothermal device. Photothermal devices which photothermal devices which converts solar energy into heat energy. These are mostly used for providing hot water. B. Photovoltaic devices. Photothermal, photovoltaic. अभी देखो थर्मल मतलब हीट, वोल्टाइक मतलब इलेक्ट्रिकल एनर्जी पोटेंशियल. Photovoltaic device which converts solar energy into electrical energy using solar cells. The solar cells works as source of DC power. Solar cell works as source of DC power. They can supply power for electric equipment at remote places on earth. That means where we can't get conventional method of current, we can construct their solar cells in hilly regions, so at remote places on earth, or remote places or on earth or satellites or a space station. Then write construction. It consists of n side, which is kept towards the sunlight, n side, and then thick p side is connected to the n side. This forms as base. P side these are two contacts. It is coated with anti-reflector. Anti-reflector, such as silicon dioxide. When sunlight falls on this, see N side, P side, when joined together at the junction, N becomes positive, P becomes negative. As light is made to incident, that means solar radiations, then energy is absorbed by the substance. It breaks the covalent bond into positive, negative pairs. This p side attracts the positive hole because it is negatively charged. P will attract positive hole, making it neutral, and N will attract negative electron, making it electrically neutral. So after excess electron absorption, it becomes negative and P becomes positive. Therefore, current flows from positive to negative when resistance is connected. Thus, it behaves like cell, giving nearly 0.39 volt. So when many cells are connected in series, we get large voltage. Connected in parallel, we get large current. So the series parallel combination can be used to give large power output. The N side, P side are joined together. N is towards the exposed surface and P is as the base. When light is incident, due to absorbing energy, covalent bond will break. Hence, positive negative pair is formed. P is earlier negatively charged, so it will pull all the positive holes and get neutralized and become positive. N pulls the negative electron, gets neutralized and becomes negative. So at its end, we get negative and positive potential. When wire is connected, it supplies the current through load resistance from P side to N side. Just draw this diagram for construction. Once you complete the diagram, just tell. Write down. It consists of PN junction. It consists of PN junction. The N side of junction faces solar radiation. The N side of the junction faces solar radiation. The P side is slightly thick and it forms the base. Both P side and N side are coated with conducting material. Both P side and N side are coated with conducting material. The N side is also coated with anti-reflector which allows visible light to pass through it. Which allows visible light to pass through it. And reflect the heat radiations. And protect the cell from heating. Two contacts are made for external connection. Then write working of solar cell. Working of solar cell. When light is incident on solar cell, when light is incident on solar cell, then first point, electron hole pair are generated, electron hole pair are generated in the depletion region. Electron hole pair are generated in depletion region of p-n junction. These are called as photo generated. These are called as photo generated carriers. These are called as photo generated carriers. Second, these electrons and holes are collected at cathode and anode respectively. Cathode matlab n side and anode matlab p side. These electrons and holes are collected at cathode and anode respectively. Third, these carriers are accumulated and generate voltage across solar cell. Are accumulated and generate voltage across solar cell. Fourth point, when resistance is connected, then current flows from positive to negative. Next line. The current produced in solar cell is called as light generated current. Or photo generated current. Then write IV characteristics of solar cell or photovoltaic cell. IV characteristics of solar cell or photovoltaic cell. voltage 0, 5, 10, 15, 20 and so on, and this is current 1, 2, 3, 4, 5. See, this is photo cell and I just connect wire without any resistance. What is this connection called as with no resistance? डायरेक्ट खाली वायर कनेक्ट कर दिया तो क्या बोलते हैं उसको?
शॉर्ट सर्किट।
करेक्ट, शॉर्ट सर्किट। वो टाइम पे वोल्टेज कितना है? जीरो ना? वोल्टेज जीरो होता है ना शॉर्ट सर्किट, नो डिफरेंस। दोनों पॉइंट को एक साथ ज्वाइंट कर दिया और करंट बिकम्स मैक्सिमम। सो दिस हाईएस्ट करंट is called as I short circuit current when voltage is zero. And if it is open, no connection at all, then what is voltage between these two points called as? Open circuit voltage. That is maximum voltage, which is also, if you remember, when battery is neither supplying nor drawing, then EMF is terminal voltage. So voltage on this is called as open circuit voltage. And current when voltage is zero is called as short circuit current. Once in entrance they had marked and they had asked the meaning of this. So if voltage is zero and current is given, it is short circuit current. Current is zero and voltage is given, it is called open circuit voltage. V open circuit, I closed circuit. Then as the voltage current starts flowing, the voltage starts decreasing across the terminal. When voltage is increasing, current starts flowing through the circuit. Due to resistance, it won't be maximum. Just draw this graph. When resistance becomes least, then power is called maximum. So at this point, this is called maximum power point. Maximum power point means from where it starts falling sharply. Maximum power is drawn, so voltage increases. Yes, completed.
Yes, sir.
Next, write criteria for selection of material for solar cell. Criteria for selection of material for solar cell. First, its band gap. अभी 11th स्टैंडर्ड से वर्ड आ गया बैंड गैप. Difference between valence band and conduction band energy is called band gap. The band gap should be between 1 electron volt to 1.8 electron volt. Generally, for any other semiconductor, it is in the range of 0 to 1.1. सोलर सेल के लिए 1 से 1.8 रखा है. It should have high optical absorption. That means it should be able to absorb the light properly. Third, it should have good electrical conductivity. Fourth, material should be easily available. Then the advantages of solar cell. Advantages of solar cell. First, they are non-polluting. They require less maintenance. Less maintenance and have large life. Disadvantage, they have higher cost of installation. They have low efficiency. Last heading, uses, then we'll stop today after completing this. Uses of solar cell. Solar cells are used in calculators. They are used to supply power in traffic signaling system. They are used in remote places. Fourth, they are used in satellite and space station. Used in satellites and space station. Yes, completed till end. Completed till end.
Yes, sir.
So that's all for today. One more is remaining. PN junction diode. After completing that, MCQ on Saturday. So Saturday this chapter will get over. Then next we'll sir has already started the chapter called wave optics.
Yes, sir.
So once I complete this chapter, I will start with revision.